All right, here's a video that should wrap up our notes for day 5 here for quadrilateral characteristics. I know we got most of the way through these in class last week. Depending on which class you were in, we kind of may have ended with this example. And so I want to kind of go over this. On example 3, we found the missing measurements for the rhombus using those characteristics. We kind of went through this, so we saw a lot of different things here, but the right angles are really going to help us when we have those characteristics. Like in this case, the diagonals are perpendicular in a rhombus. Well, that's what created this right triangle. These right angles create these right triangles, and so that helps me. And actually, all 4 of these right triangles are the same. So when it asks for the length of ZV, they ask for this length here, we could do Pythagorean theorem because we knew that one of the diagonals, WY, was 38, and half of that, because the diagonals also bisect each other because it's a parallelogram, then these are both 19s. And then that this side, ZW, was 34 because it's the same as ZY. All 4 sides are 34. So I could use my Pythagorean theorem and do 19 squared plus B squared equals 34 squared. When we solve that with the Pythagorean theorem, we get 28.2. Okay? Now, for the angle measures, we kind of just went through this. Remember things like this. In any parallelogram, not just rhombus, but in any parallelogram, we have parallel sides. So these opposite interior angles or alternate interior angles are congruent. We found a lot of different things through that one because the diagonals bisect opposite angles. Consecutive angles of any parallelogram are supplementary. We use some of that. And so that's how we find these other angle measures. And then all 4 of these angles around V are 90-degree angles. Okay, so if you have any questions over that, we can go over that again next class as well. But I wanted to finish up and talk about these last few examples from our lesson for day 5. So as we look here, we've got example 4. This is a square, and all that we're given is that AD is 11. Well, a square has all the properties of a rhombus, so all sides are 11. A square has all the properties of rectangles, so all of these angles at the corners are right angles. And because it's also a rhombus, the diagonals bisect each of those right angles, so every one of these smaller angles is 45 degrees. Okay, so all 8 of those smaller angles are 45 degrees. And so when we go through asking these questions, it asks for BC, that's another side of the square, that's 11. AC is one of the diagonals. To find the length of AC, we can do Pythagorean theorem because we get this right triangle that is half of that square. So we can do 11 squared plus 11 squared equals that length C squared. I'll just call it AC squared. That's the length I'm looking for. 11 squared is 121. So there's 2 of those, so I'm going to double that. That's 242. And then I do the square root of both sides. And we get about 15.6. It's like 15.55634,919. So we'll just round that to 15.6. Then it asks for EC. Now EC is half of that. So I'm just going to take my 15.55634,919, divide that by 2, and I get 7.8. Or if I just did 15.6, that's 7.8, rounds to the same thing. So EC is half of that length because the diagonals bisect each other. And then for our angles, most of the angles are pretty easy to figure out. DAB is one full angle of the square, that's 90 degrees. AEB, that's one of these angles formed by the diagonals. The diagonals of a square, just like that of a rhombus, are perpendicular, so that's also 90 degrees. And CBD is exactly half of one of those right angles, so it's 45 degrees. Okay? All right, and that leads us to talking about our next examples where we're looking at trapezoids. When we talk about trapezoids, If we have any old trapezoid, it's a lot less likely we're going to have a lot of different things to figure out because we don't know a whole lot of information about that. Except we do know consecutive angles that share what we call a leg are supplementary. So to find like the measure of angle M, I would do 180 minus 87. That would be 93. So the measure of angle M is 93 degrees. And to find the measure of angle K, that's a consecutive interior angle with this 51 degrees. So they're supplementary. So I'm going to do 180 minus 51. And that's 129 degrees. Okay? But when we have a isosceles trapezoid, we know that part B here is an isosceles trapezoid because these sides are marked congruent, so both the legs are the same. Okay, the legs are equal. That means these base angles that share a leg are the same. And then these base angles down here that share this other base are the same. Sorry, base angles that share a base are equal or congruent. So angle W is also 47 degrees. Okay, to find the other two, we're going to take 180 minus 47 for this one, and that's 133. So angle Y is 133 degrees, but so is angle Z. Okay, and I could think of it this way. If I split an isosceles triangle down the middle, and I fold this half over to this half, they're going to be exactly the same. This has line symmetry straight down through the middle, so this half is identical to the other half. So that's how I know that these angles that share the bases are congruent to each other like that. All right, we're also told this is an isosceles trapezoid. Okay, DEFG is an isosceles trapezoid. I want to know what segments would be congruent because of this. Well, first they say DG. Well, DG is one of the legs. It would have to be congruent to segment EF. And then DF is one of the diagonals. Well, in an isosceles trapezoid, diagonals are also congruent because we kind of have that same vertical symmetry here. So this other diagonal, GE, would also be congruent to DF. Okay, that finishes our lesson notes for day 5. You should be able to finish the day 5 worksheet. We're not going to do any new worksheet yet for this lesson. For the next lesson, we're just going to go ahead and wrap up that worksheet. And if you have any questions, we'll answer them next class.